the traffic back to customer side. The PL gateway and the VPN gateway can back up each other. Sorry. By deploying SDR, we can easily interoperate with both the traditional customer networks and SDN-based VPC networks. Moreover, SDR can support up to 10K tenants per tenant rate limiting and the statistics for billing. All these capabilities can scale up as needed. Okay, this is the end user access scenario. For this scenario, we deploy the SDR as TICS with Tencent Internet Exchange to communicate with both the ISP routers and our internal VPCs. Again, EA is used to connect with the ISP routers and does ISP isolation via layer 2 networks. BGP session is established between TICS and the ISP. The routing information will be propagated to VPCs and other SDRs. For traffic engineering purpose, the VXLAN fabric has been built across the whole SDR domain. For inbound traffic, after ACL processing, SDR forward the traffic to corresponding VPCs. For outbound traffic, SDR uses the BGP routing information along with the flexible rules to choose the best exit for user traffic. Sometimes SDR may forward traffic to another SDR traversing Tencent backbone network. Okay, the key challenges for this case include massive scale routing table and the various traffic engineering requirements. By deploying SDR for TICS, both of them have been greatly improved. Next, I'm going to take some use cases to demonstrate the flexibility of SDR. Most of the time, BGP can work well for traffic forwarding. However, it's not enough, as BGP just indicates the network reachability based on the shortest path of destination IP. And sometimes we need to take more metrics like source IP cost into consideration for the traffic forwarding. For TICS scenario, we like to differentiate services to better use our edge resources. So for example, we want to schedule the lower QoS required traffic to a particular exit for cost purpose. So to do that, we program flexible rules as source IP, destination IP tuple mapping to a specific exit into the SDR data plan to override to the BGP route. Even more, we can encode the VNI to identify one specific peer among multiple peers in one site for fine-grained traffic engineering. Yeah, of course, we had to inactivate those flexible rules and fall back to use BGP for packet forwarding when the related BGP routes are withdrawn. Moreover, as the traffic is transmitted via VXLAN fabric, all of these overlay forwarding rules are transparent to the underlying network, so we can still keep the underlying network simple. By doing this, we have greatly improved the flexibility for both Tencent cloud services and Tencent own services. Actually, we have received lots of such requirements from our business teams. This one, next one is about the security service. We deploy firewall service associated with the SDR for security purpose. For one specific user's traffic, the firewall service needs to be fed with both the inbound and outbound traffic. So to do that, we program flexible rules as destination IP mapping to the firewall VNI tuple to steer inbound traffic to firewall service, and rules as SIP mapping to firewall VNI tuple to steer outbound traffic to the same firewall service for security processing. To allow flexible deploy firewall service, we also have built VXLAN fabric between the firewall service and the SDR. Currently, SDR can support up to 100K flexible rules for firewall purpose. And we can scale up them as needed. Apart from the firewall service, we also deploy DDoS service associated SDR, especially for the TIX scenario. A DDoS is just for the inbound traffic. Once the attack traffic detected DDoS, it uses the BGP to advertise the related routes to SDR. By programming the routes into data plan, SDR is able to redirect the attack traffic to DDoS. Yes, same. It's very simple. It's very easy. However, the DDoS traffic is always short burst and high volume. So to protect our servers, to protect our data plan, we want to redirect the attack traffic to DDoS service at EA instead of data plan. To leave our data plan only handling the real traffic. At the attack traffic, we just describe is forwarded based on layer 3 routing table. That means the EA has to act as layer 3 switch. However, in our design, EA works at layer 2. How a layer 2 switch forward traffic based on layer 3 routing table. This will, thanks again to the flexibility of server-based programming. With a minor modification of SDR, neighboring system, and some configurations on EA, EA is able to use the routing table to forward traffic. So specifically, attack traffic will be redirected to DDoS service at EA switch according to the rules advertised from DDoS service, and the normal traffic will be forwarded to data plan according to the default route pre-configured on EA. And for the outbound traffic, EA still works at the layer 2 network. By leveraging the flexibility of server-based programming and standard function of commodity switch, we're able to build a flexible and robustness DDoS service for our customers. For practical reason, SDR has to support incremental deployment and interoperate with the existing traditional router inside Tencent network. As this is different from the interoperating with the outside network. Okay, this is just for the Tencent inside network. And the traditional routers are running in MP